So good afternoon, everyone, or good morning, good evening, if you're joining us from outside the UK. Welcome and thank you for joining us for this Carbon Energy Fund webinar in partnership with IHEM and HEFMA. My name is Jonathan Stewart. I'm the National Chairman of the Health Estates and Facilities Management Association. I'll be chairing this webinar session today, where we have a panel of speakers for you. The webinar will be presented by Stephen Lowndes, Technical Director of the Carbon Energy Fund, Stephen Heath, Technical Advisor and Project Manager for the Carbon Energy Fund, Guy Keyser, Associate Director of Estates from the Royal Berkshire NHS Foundation Trust. And the title of the presentation is Introducing a Healthcare Engineering Roadmap for Delivering the Net Zero Carbon. We will be using the questions function to take questions from the audience. So this can be found at the top right-hand side of your screen, and it's the icon with the little question mark in a speech bubble that will appear during the presentations. We won't have time to use the audience hands up facility, so please post your question to the organizer and our speakers will answer as many questions as there is time for at the end of this session. Please note that a certificate of attendance will be sent to all those who watch the live webinar in its entirety. We request that no part of this webinar is reproduced and published in print or any other format. So that having been said, I'd now like to hand over to Stephen Lowndes from CEF to start the presentation. Thank you. Stephen, where you go.
Thanks very much. Next slide. So this session attempts to align the objectives set out in a recent UK government decarbonisation goals. And specifically relating this to the NHS governance around approaching targets for net zero, and therefore how do we roadmap our way towards those goals. So we're going to consider first of all what that net zero target actually means for the NHS estate and how we can start to plan our way forward given some of the limitations on technology available today, and also thinking about some of the practicalities of actually delivering that on the ground. You move to the next slide, please. So, as you're probably aware, in October last year, the NHS published its Delivering a Net Zero National Health Service report. This identified targets for decarbonising, and the objective really was to achieve a net zero emissions position by 2040. This is a pretty ambitious timescale given the UK government net zero target itself is meant to be 2050, so we're sort of 10 years in advance of the overall country's targets. These targets relate to the CO2 emissions of that the NHS actually control directly, the so-called NHS carbon footprint. And we'll look at that in a little bit more detail shortly, as well as some of the emissions that the NHS influence indirectly. You can go to the next slide. Just to remind ourselves, what does actually net zero mean or infer? It actually means that any remaining footprint carbon emissions, they'll be balanced by other schemes to offset an equivalent amount of greenhouse gases, such as planting trees or using technology like carbon capture and storage. So in other words, if I've done my best to reduce all my emissions from the estate and estate activities, but there are, and there probably always will be, some level of carbon emissions that I can't stop or curtail, then these will need to be offset, probably by purchasing carbon offsets. And they pay for carbon emission reduction projects or activities elsewhere that save the equivalent amount of emissions that I can't reduce on my site. So to a certain extent, we can do this now, actually, when we purchase the so-called green tariff electricity from Crown Commercial Services. We're effectively choosing to pay slightly more over and above the cost of normal rate electricity, but on the basis that we are effectively supporting green energy production. But the trouble with relying on offsets is that they don't actually do anything to solve the CO2 problem in themselves, and so really they should only be relied upon at the point of us having done our best to manage what we can actually control by limiting our emissions in the first place. Otherwise, if everybody in the public sector relies upon offsetting, then there's going to be no actual carbon reduction to the public sector estate at all. Excuse me. You can go to the next slide. This graph shows the NHS timescales to date for total greenhouse gas emissions of the NHS in England. It's broken down by source of emission for 1990 to 2019. We can see that estates water and energy historic use are shown in the pink and pale zones at the bottom of the graph. It shows under this set of measurements that buildings water usage alone has declined from approximately 25% in 1990 to around 20% today. You notice that the time base of the emissions historically and going forward is based upon a 1990 baseline. So why have we chosen 1990? Well, 1990 ties in with the UK national emissions baseline, and that's the basis used in the Kyoto International Climate Change Agreement, to which the UK is signatories. So the UK emissions reductions first became legally binding in the 2008 Climate Change Act, and that's targeted an 80% reduction by 2050 from a 1990 position. In 2019, the UK set the 2050 emissions target to be 100% net zero by 2050. Next slide. So, as promised, a quick explanation on the NHS carbon footprint. This relates to the emissions the NHS control directly, i.e. NHS carbon footprint, which includes energy use in buildings and in vehicles owned or controlled by a trust, water, waste management as well as obviously medical related activities such as medical gas, etc. The NHS carbon footprint plus, which is the thing you can see on the left-hand side, right-hand side, that considers the wider influences that the service has with suppliers, and setting that, the setting in which that sort of operates, I guess. So the examples, for examples of how the NHS utilises construction, where it sources food from and how it delivers support to business services, that's all in that wider NHS carbon footprint plus. Also, the scopes referred to, scopes 1, 2 and 3 in that diagram, they relate to the International Greenhouse Gas Protocol, and that stipulates the silos against which carbon emitting activities reside. Generally speaking, carbon reduction legislation and corporate reporting today, that's majored on scopes 1 and 2 activities, and these are the easiest to measure. But scope 3 is probably the widest reach, and as we'll see, it probably dominates the other 2 scopes in terms of its impact. We'll go to the next slide, please. This graph is taken from the NHS Net Zero report, and it shows pie slices for the sources of carbon emissions by proportion, the NHS carbon footprint plus. So this is the wider, the whole carbon footprint for the NHS, and it shows 20% is related to buildings and building services, 10% for building energy, 5% for water and waste, 5% for medical gases. you can see by the comparison to the medical equipment and medicine upstream supply chain, the proportions of direct estate emissions are less influential. But we've got to remember that the wider NHS footprint plus encompasses supply chain emissions, which the NHS has less actual direct influence over. You can go to the next slide. So we're essentially looking at the NHS estate, and what's the biggest area we can have the biggest impact on, which is in the NHS carbon footprint, and that concentrates on the emissions that the NHS can directly influence. So this footprint is more directly taking the impact of the estate into the account. It's because of the reduced scope 3 emissions compared to the wider carbon footprint plus what you saw on the previous slide. It means fossil fuel used in scope 1, like natural gas and electricity use in scope 2, they'll have a bigger influence over the total scope emissions. So when we talk about the NHS carbon footprint, building and estate energy use has now become a much more significant influence. You go to the next item. You can go to the next, that's it. So basically the NHS guide suggests that significant interventions are going to be needed to the retained estate. And this slide shows the interventions to reduce emissions in the secondary care estate. So if you do the first click, you'll see that if you click on that slide, that's it. So we need 20% savings against present day emissions from building upgrades. And if you click again, we need 24% emissions reductions coming from optimizing building energy usage. You give us another click. 25% of those are going to need to come from generating renewable heat and other renewable energy. If you click again, we need 14.5% decarbonisation, which is going to come from the national grid. And if you do another click, you'll see that there's still 6% emissions reductions that have still got to come to get us towards that net zero position, but we don't know where they're going to come from yet. And there's hope that that's going to come from some innovation and some R&D. If you go to the next slide. So 2040, the net zero target date, that seems like a long way away from where we are now in 2021. So many of us might have finished our careers by then perhaps. But actually, the NHS targets are more ambitious, and they place more urgency on the speed of change and adaptation needed. The guidance tells us quite plainly that for the emissions we control directly, the so-called NHS carbon footprint, well, their ambition is to achieve an 80% reduction in emissions by 2028 or 2032 at the latest. So that means most of the emission reductions we need to make in order to achieve the 2040 net zero position need to have happened in the next 10 years. And that's quite a sobering thought. And it means that we need to start planning and working out how we're going to do this now. You go to the next slide. This graph is taken from the guide, and it shows the anticipated carbon reductions needed. The green dark line to the left of the chart, that's the historic emissions up until 2020, and the dark green line then splits into two dark green dash lines. They both transverse from 2020 towards 2040 and beyond on the right hand side of the page. The topmost dark green dash line, that indicates the do nothing scenario, and that assumes that there's no further decarbonisation of the electricity supply grid. The bottom-most dashed line, that shows the actual carbon reduction needed to evolve now between now and 2040, and that's the line that hits the net zero axis. So we then see how the reduction from the top do nothing line down to the bottom target line, that's divided up into the various reduction slices on the NHS carbon footprint. It shows, but by 2032, the point at which we need the 80% reductions, the growth in emissions that is going to be needed from existing building and efficiency on site, renewable generation, etc. You can see from that sort of red arrow that is quite a significant increase and acceleration to those reductions that are going to be needed between now and the end of the decade. You go to the next slide. Probably off the back of that, the biggest challenge for us now is really how are we going to decarbonise our heat? How do we move away from fossil fuel gas and oil over to either more renewable heat or over to greener electricity in the short to medium term, possibly even hydrogen in the future. So this chart is showing that whilst there's been a significant progress in reducing emissions from electricity generation in the last decade, that process in decarbonising the heat has been very slow. From 2010 to 2018, there's only seen a 67% reduction in emissions from electricity generation sector, and that compares with almost negligible reduction from the heat sector. So it implies that really moving over from fossil fuel gas to cleaner electricity for heat, that's going to be the most effective decarbonising building energy action you can take. Take the next slide. You see that unfortunately the other side to this is that yes, while switching over to green electricity to heat may save carbon, it's probably at the moment largely completely unaffordable at scale. This graph's showing how the steep rise in electricity costs in the last 10 years. It shows there's a slight tail off in 2020. That was due to global turndown from COVID impact. Wholesale prices are expected to pick up in a rising trajectory. There's no current financial encouragement to put more of our energy over to green electricity. If you go to the next slide. So actually, it looks even worse when you look at the prices for gas. They remained pretty low for many years, comparing that to the rising electricity. So effectively, what you've got now is quite a big spark gap, and that's the difference between the cost of electricity and gas for each kilowatt hour of energy you use. And at the moment, it's never been greater. And you can see the graph is just showing gas prices are roughly around the typically 2 pence a kilowatt hour, and they've been around that sort of margin for quite some time. We go to the next slide. So the other influence is obviously cost of carbon, and some of us, we've already been subject to specific carbon taxes through what was called the EU ETS, the Emissions Trading Scheme. And that had hospital opt-outs in it for those that qualified, but even so, it still presented a challenge with progressively lowering emissions thresholds. So it means a risk that some hospitals pay out for exceeding CO2 limits year on year, and that's become higher and higher as the cost of carbon has gone up. So obviously the UK exited the EU ETS because of Brexit, but there's a new UK ETS that started this month, and that's just as likely to bring similar pressures to bear. If you go to the next slide. Effectively, what we've seen is the UK's legislated to reduce its net emissions, and that's trying to achieve a net zero by 2050. December last year, the Prime Minister announced that he wants to achieve a 68% reduction by 2030. Obviously, that compares with our 80% reduction by the same date. 30 or 40% of those emissions are going to be taken from anybody who's in the EU ETS. So you're going to pay for some of those emissions reductions via that scheme. The government is currently reviewing, as part of its strategy to deliver a carbon price for the whole economy. It's currently looking to see if it can introduce some further carbon pricing. So that actually means that we're probably going to see carbon prices coming down scale to all of us in some form or another, not just those big emitting sites. So carbon cost is likely to come into view in the next few years. We go to the next slide. So really, all this is pointing to the difficulty of planning against uncertainty of immediate government plans in terms of cost. But really, we can see in the medium to long term, it's really quite clear. We have to start taking steps now, and we've got to set out some roadmaps to net zero. So if you go to the next slide. The roadmap, what should it do? It needs to take action on what is possible to do now. So what technology is available? You know, what are the costs of that? What's affordable, and what's going to work with our own particular sites and how they're going to develop over the next few years. We need to act on any funding schemes that become available. We've seen the PSDS SALEX funding that's arisen in the last year, and there are going to be some further phases to that, and that will help us in affording some of the major alterations and improvements that we can do now. We need to ensure that any solutions we deliver today, we need to ensure that they don't annex us from further improvements in the future. So that means really being very clever about how we plan things. So, for example, we might replace high temperature heat infrastructure today because we know that that can be used with things like heat pumps, which are low carbon heat sources. Whereas if we just replace high temperature heat infrastructure with more high temperature infrastructure, when we're going to be unlikely to move away from anything other than gas boilers. We need to get the infrastructure in place that enables the future to be more easily built. So things like de-steaming and moving to more efficient heat delivery. So we may not be able to do everything and convert everything over to electricity today. You know, that's unaffordable, and really it's not practical. We can't heat all of our sites totally from electricity. There will be areas that can be dealt with initially, and others that will be better served after we've done some fundamental sorting out of other stuff first. So that's why we need to stage our strategy. We've got here a sort of basic 3-stage plan. We need to start to map out for our own individual sites, and they identify, and that plan needs to identify our priorities, stuff that we can do today and stuff that will facilitate improvements for tomorrow and get us to the end game position. Go to the next slide. So it's going to vary from site to site. It's got to be strategic. And any investment we make now, it's got to be adaptable, and it's got to go on to enable further enhancements and improvements from more technology innovation in the future. Yeah, so this slide is showing the staged approach what that might look like if you plan that out against its carbon emissions. You can see that we can actually plan out what emissions might be now, because we've got the information to be able to do that. The red line just shows us the carbon savings delivered by an energy project that started a few years ago. The green line's the carbon emissions of the estate historically, and where it goes dotted, it's the route towards net zero. And the black dash line is where the emissions might be without the energy project. So you can see that this scheme showed some good savings in the past, but they've largely disappeared. So it's showing us that some further reinvestment is needed to get us towards that zero trajectory. Go to the next slide. When we plan this out, we've also got to forecast what it's going to cost and how it's going to work in terms of running costs. So it might be we can forecast those energy costs and the savings, even if we don't know what the full extent of future carbon taxes might be. Some schemes will show significant savings, but that might not be the case for all expenditure. You know, for example, at the moment, heat pumps might actually save the most carbon, but they're probably going to cost more to run compared to gas boilers. Go to the next slide. So if we plan for these alterations to existing energy infrastructure now and the building schemes, we know what the timescales are and the extent of carbon reductions needed to hit as close as we can to net zero, so we can start to look to ensure solutions deliver long-term benefits, that they persist beyond the current, you know, what maybe in the current lifespan of some of the improvements that we make. So we can map these out like this graph is showing. We can see here it's showing an additional stage to that original energy project, and that's showing it moving further towards the net zero line by using putting efficiency improvements into the CHP, de-steaming, maybe adding some heat pumps and solar PV. So it's showing us getting there further on, but obviously you can see that even more investment will be needed a bit further down the line to get us at least towards that 80% position. If you go to the next slide. So sort of in conclusion, what we're saying is we know where we need to be, and the essence of this now is about planning strategically how we get there, knowing now the trajectory that we need to try and hit. In these next sessions, we're going to look in a bit more detail about some of the key aspects of the energy schemes and technology and how they can be planned for. We've got some examples coming up which show some of those first stage improvement projects working in practice. Thank you very much.
Thank you, Stephen. That was really insightful. And as we can see that there is, you know, a big challenge ahead, but it's an exciting challenge in many ways. I'm going to do a quick canter through an example scheme and look at some of the what might be coming down the line at us. But as a group of NHS estates professionals, there's lots of exciting opportunities. It's an interesting and intriguing and exciting puzzle to investigate and resolve. And there are many people, probably many of you on the call right now, who are already, you know, actively looking at this, particularly with the recently released public sector decarbonisation scheme, which is already on its phase 2. So I can advance the slides, which I can't.
We've lost your sound, Stephen.
Hello, can you hear me now?
Yes.
Brilliant. Okay, so I'll start again. NHS estates are such a wide and intriguing and eclectic mix of property. We've got wonderful, sparkly new PFI hospitals. We've got Victorian buildings which have their own beautiful challenges. We've got things that were built in the 90s, things that were built in the 60s. We've got, you know, secure mental health units. We've got small community hospitals, and they all have different challenges and different things and different problems to solve. So in terms of the strategies of going through the different stages that Stephen talked about, they will be different for each trust and each site, and how and the options for one may not. There's no one cookie cutter approach of one size fits all. Next slide, please. So, as Stephen mentioned in his presentation, the carbon intensity of the grid is changing and is due to reduce significantly over the coming years. And in around 8 years, we'll have parity with gas. So a kilowatt hour of electricity will generate the same carbon emissions as a kilowatt hour of gas. That's, you know, when you think about where we were even 10 years ago, that's quite a phenomenal change. So that changes the technologies that we're looking at. And as we said, we can't, the images on the screen, you're probably, the one on the left, I'm sure many of you are familiar with. It's a medium temperature boiler house. Actually, that one there is no longer looks like that. It's been recently ripped out and replaced with a modern alternative. But that modern alternative was certainly not the picture that you see on the right, which is a large-scale industrial heat pump, because there are many, many challenges for us to move in one step. From the picture on the left to the picture on the right, but we'll get there. So next slide, please. So under the public sector decarbonisation scheme, the latest phase, each application has to have one of 4 technologies: either biomass, district heating, or heat pump technology. Now, I think it's worth on this short presentation just doing a quick recap on heat pumps. We can generally describe them in 3 types: air source heat pumps, which are using electricity and the ambient air to produce heat; ground source heat pumps, these are ones which typically have boreholes or some form of surface ground collector to harvest the heat, and again, electricity is always used to power the heat pump; and water source heat pump, so you might be drawing water from an aquifer through the heat pump to harvest the energy in the water. Sorry, can I have that last slide back, please? Thank you. An important point to note, though, and it's easily confused: ground source heat pumps are not geothermal. Geothermal is where we're taking energy from the core of the earth, whereas ground source heating is heat that's harvested from the sun's effect on the surface of the earth. There aren't many geothermal reserves in the UK, there are a few, but so generally when we're talking about ground source heat, we're not talking about geothermal. Could I have the next slide, please? Okay, so just a quick recap. So on boiler efficiency, so in a regular boiler like we might find in any hospital estate, you've got gas in, heat out, and then the difference between the two is the efficiency. So, you know, typically on a megawatt boiler, you put a megawatt of gas in, you get 850 kilowatts of heat out, and so the unit's overall 85% efficient. If we flick onto the next slide, we can see what that looks like with heat pumps. There we go. Next slide. There we are. Thank you. So heat pumps have an efficiency, but it's referred to as a coefficient of performance. So for example, in this example, if we put a kilowatt of electricity into our heat pump, and that heat pump has a coefficient of performance of 5, then we will get 5 kilowatts of heat out, meaning where the heat pump is harvesting 4 kilowatts of energy from the environment, be that air, ground or water. So it is highly efficient. And if you think about that multiplier with when the carbon factor is at parity with gas, suddenly, you know, our heat pump is going to be 5 times more carbon friendly than the gas boiler equivalent. And even more when you take into account the efficiency of the boiler. Next slide, please. So there's some other things. So in terms of with air source heat pumps, they where the boiler with our old-fashioned gas boiler, it's going to be about 85% efficient, or whatever the efficiency is. It will do that mostly throughout the year, whether it's cold outside or warm inside. It might vary a teeny tiny bit, but it's not going to vary very much. Whereas heat pumps are very susceptible to change in outside air temperature. Air source heat pump is very susceptible to change in outside air temperature. So the efficiency, where the COP might be 5 or so in the summer, when it's 15 or 16 or 20 degrees outside, when it's -5 in the winter, it's probably not much better than an electrical resistance heater. So we need to think about how we integrate that type of technology into the systems we have right now. Next slide, please. And this, oh, 2 slides forward. So, well, the previous slide, which we're reading it, is basically makes the point that the output temperature of the heat pump also affects its efficiency. So the higher the output temperature, the lower the efficiency. So with new build, we've got obviously, there's the HIP2 program around, and so there's a number of trusts which are looking at designing new builds. Well, that heat pumps are better suited to lower temperature systems. So where we're designing new healthcare facilities, we have a wonderful opportunity to look at building engineering solutions which are inherently low temperature distribution systems, because they better suit the future technology. Next slide, please. Looking specifically at healthcare applications, hospitals are more challenging for heat pump technology. Why? Because we have hospitals, particularly acute hospital sites, they've been designed with low temperature hot water networks which run at 80 degrees or medium temperature at 120, or there are still quite a lot of sites which still operate on steam. So integrating low temperature heat pump technology is challenging. Community mental health ambulance station type facilities are slightly easier because the systems are simpler, but we still need to bring those flow temperatures down to make them more compatible with heat pump technologies. So we need to think of creative ways of integrating heat pump into healthcare estates. Next slide, please. So let's have a quick look at a sample decarbonisation for an acute hospital. So this is just one example of a site, of an example that's close to a project I've done recently. So here we've got a hospital. It's on steam. You can see that the boilers are definitely end of life. They're well past their best, and the distribution system, the steam distribution system, is end of life as well. The mains and the condensate return system is in a shocking old state. So, and it's high on the backlog maintenance. It's high risk. So we need to do something with it. Next slide, please. So it's a great opportunity to move from steam to low temperature hot water. It's going to be capital intensive, and it carries a level of risk because we're doing open heart surgery on the hospital, but it should be manageable whilst maintaining N+1 resilience. It's going to take the site out of the pressure systems regulations, so we're not doing all those strip downs, which is quite costly, and all the insurance inspections and so on. And it's an opportunity to redesign the distribution system so it's going to be compatible with low carbon technology, some which we can put in now and some which will be coming along in the future. And the LTHW will have lower thermal losses compared to steam. It's going to have more electrical demand for pumping, but in comparison to the losses, that's kind of small beans. But we also need to look at the secondary side of the system, so we're reducing the return temperatures. We don't just want to put in LTHW with an 80-degree flow. We want to get it down to 70 or below if we can. Obviously, noting the points around Legionella, so we have to have the take that into account as well. Next slide, please. So with this project, we're going to move to low temperature hot water. And wouldn't it be nice if we could put some sort of heat pump technology in today? So we're going to need to put in low temperature hot water boilers for this new network. They'll deliver some efficiency improvement. But we can also look at putting in some heat pump technology because there's heat pumps out there now that will produce up to around 70 degrees with an efficiency trade-off, but it still, has an overall benefit. So next slide, please. So here we can see what we can do. If we've got our low temperature network and we've got it running effectively, we can put a heat pump in on the return leg back to the boiler house, and we can look to preheat the returns with the heat pumps before it gets to the boilers. So we're starting to begin building heat pumps into that low carbon technology into our solution. Next slide, please. So, but all of this costs a lot of money. Now, CHP engines are in the next few years are going to become net carbon emitters, even really, really highly efficient ones. But they are also revenue generators, and they can help fund these kind of very expensive projects through the huge energy savings they can deliver. So next slide, please. So I think it's important to just take stock of when they become net emitters and the overall impact. So if we look at this graph very quickly, we've got, you can see that with a very highly efficient gas engine where we're capturing all of the heat, we will be able to get to, the engine will become a net emitter in around 7 or 8 years. But overall, it won't have actually be a net emitter cumulatively until about 12 years. So that gives us an opportunity to use the CHP in the way, just like Stephen said earlier, to help build that project and make it work. Next slide, please. But to make it work, they need to be absolutely super efficient. So we can look at using another heat pump here. CHP engines have an intercooler heat circuit, which 99% of the time just goes through a rejection radiator because it's only 40 degrees C. So we can look to integrate that with a water-to-water source heat pump to use that to upgrade that intercooler heat to around 70, so we can put that back into our low temperature network as well. Next slide, please. So here we now have our fully developed solution. And in all of these solutions, we must remember we focus on the large infrastructure in this presentation, but all of those demand side measures in terms of energy reduction are equally important and should always be considered as part of any energy project. But here you can see we've got the heat pump picking up the load first, then we've got our CHP, which has its jacket water, which is feeding into the return leg. It's got intercooler heat, so it's taking the intercooler heat, upgrading it with another heat pump, putting that back into the return, and then finally the exhaust gas heat exchanger, putting the third component of CHP back into the network. And then hopefully those low temperature hot water boilers are going to spend very little time doing any serious hard work, except maybe in the peak of winter. Next slide, please. Okay, so in summary, our D-Steam project, we've taken our steam network, we've changed it for low temperature hot water, we've adapted the secondary, so we've got around a 70 degree flow rather than 80. We've put in high efficiency LTHW boilers with a hybrid heat pump. We've got a gas-fired CHP, but that's not an ordinary one that we designed to use absolutely every last kilowatt hour of heat, no heat rejection. We've put that and then that little heat pump in for the intercooler circuit to boost that. We've included energy conservation measures, and with the help of the CHP, we've probably got a cash positive business case, and we're getting our carbon in the early years, and with those larger scale heat pump technologies when they become commercially viable. And so there'll be a point in the future where the CHP comes out, maybe 1 or 2 of those boilers come out and are replaced with the larger scale heat. Next slide, please. Okay, so finally, just the last slide, just a quick one. There's a lot of talk about hydrogen. Hydrogen has the potential to realise significant heating decarbonisation benefits, but only for some. So where there is a project for injecting hydrogen into the natural gas grid, And if you're a hospital that's right by one of those projects, then you might be able to take advantage of that. But in any case, they're all still some away. But if you're replacing plant, you should give consideration for purchasing plant that's hydrogen ready. And just a note on terminology with respect to hydrogen. The hydrogen is described in two ways: blue hydrogen, which is hydrogen which is made from reforming natural gas. And the idea with that is we use gas, we reform it, we capture the CO2 and put it in long-term storage, and we inject hydrogen into the national gas network. And then there's green hydrogen, where we're using excess electricity generation from renewables and putting it through electrolysis to make hydrogen. And again, that can go into the gas network, which you can use in your boilers and CHPs and so on and so forth. But I think there's another whole presentation on hydrogen. Anyway, next slide, please. That's all we've got time for now on that, and I will hand it over to Guy to tell you a little bit more about what's going on the ground. Thank you, Guy.
Thank you, Stephen. See if I've got control of my mouse. And hello from Royal Berkshire Hospital. Just by way of introduction, I'm Guy Keys. I'm Associate Director of Estates for Royal Berkshire Hospital. I've been invited just to tell you a little bit about the project that we've undertaken and what we're going through at the moment, feeding on from what both Stevens have been speaking to us about. By way of introduction, a bit of preamble. We are a principal provider of acute and emergency healthcare services through the population of West Berkshire, part of the Bob IC STP. We have an estate that was built back in 1839, was opened up, long rich history in Reading, in Berkshire, and one of the largest district general hospitals. So our estate is one that is sprawling throughout the grid that we've been developed in. And really just need to impress on you where the extent of our estate. We are made up of many different, I would call it a multi-site hospital, effectively about 9 different blocks in varying ages. So to the top of your screen, you'll have W1, 2, 3 and 4. Those buildings are 1940s buildings. To the right, we've got our oldest buildings built opened up in 1839. And then working your way back through the hospital from right to left, we have various buildings of various configurations and types, with our hot side, that is where all our theatres are, and emergency services in the centre and to the left. We have about 660 odd beds in the hospital, so it's a very, very busy hospital, 24/7 operation. So when we're considering de-steaming a site like Royal Berkshire Hospital, it is a very complex and challenging job to undertake. But we are very fortunate in that we are one of the hospitals that's been put on the health infrastructure plan by the government. So we'll be one of the 40 hospitals that's been selected to be developed over the next 10 years. One of the 21 trusts that received seed funding to develop the ideas around how we redevelop our hospital. That's been in consultation over the last year. And our strategic outline case was submitted on the 21st of December for consideration, waiting for that to be returned. All development opportunities are on the table at the moment. There's four options of doing minimal, so pretty much a lick of paint and refurbishing what we have, through to knocking down various parts of the facility and rebuilding to a complete new hospital off-site. But any one of those options would take anything up to 10 years to come to fruition. So we have a backlog maintenance to the value of about £63 million. Our estate is served through energy from a central energy system, and distributes a network of steam through to each building, where it is absorbed and converted into LTHW, low temperature hot water, and distributed to heating systems, be it hot water or radiator circuits or heating and ventilation plant. So we got at the very heart of our considerations when we're thinking about the redevelopment of a hospital are the two items that are highlighted: the energy and the climate considerations. What do we do in order to address these very challenging issues that both Stephen's been talking to us about? Because we need to start to invest now if we're going to achieve any of those goals by 2028, 2032, and certainly put us on a path to 2040. And one of the conundrums I'm sure you will all be involved in trying to resolve is how, with a very old estate and an infrastructure that's failing and in need of investment each year, how do we do that with an eye on the future? If we were to take it as a piecemeal project for each building, and replace what we have in those buildings, i.e. steam clarifiers, and steam pipe work and condensate return, we would be buying into and investing into systems that would lock us into another 25 years of depreciation, and give us very little opportunity to address the issues that we've been speaking about. So our considerations at the very start of this is, how do we address the energy issues? How do we address the carbon emissions and the fossil fuels issues that we have to address up front in order to reach those targets in the future? So that's the background. We have a 15-year energy performance contract that we engaged in with Veolia, who run that for us, procured through CEF. We are 7 years into that, so 8 years left on that existing contract. They maintain the boiler house, the combined heat and power system, to the point of distribution, so where it leaves the building to the rest of the estate. It is then managed by a fully managed service that we have with a service provider through the rest of the hospital. And that's about 1.5 miles of steam pipe and steam condensate pipe, steam out and condensate back. And then connected to that is all the other pipework systems, so the tertiary side that connects to air handling plant and radiators, all of a similar age, so 60 years through to our newest building, which would be about 20 years old. We have annual revenue losses of about £350,000 just through the steam leaks that we're experiencing and the condensate return that's not getting back to the boiler house, and the investment we need to make each year to carry out repairs to failing systems. And each time we carry out those repairs, we're very conscious that we're investing in something, yet again, that should be there for another 15 to 25 years of life cycle, which is poor investment. So we needed to take the approach, what do we do with this opportunity that we have, being part of the government's HIP funding, Health Infrastructure Plan funding. And part of that is the HIP2 funding that became available to us in the middle of last year. Thankfully, we were already in the process of engaging in how we address these issues with CEF from 2018. We already had meetings to talk about how to address this as a long-term issue. So when I got the call one Sunday morning to say we have to submit a proposal for HIP2 accelerated funding to the tune of £30 million and what projects were available, this was obviously our first choice in terms of how we tackle the sustainability issue and carbon emissions. So the funding was approved in September. The challenge to us was that we were having to try and deliver what would effectively be a 1 to 1.5 year project within about 6 months. But we were well on the way with that, with the outline schemes that had been developed in collaboration with CEF and Veolia. And we're already in an EPC contract with Veolia. So as a variation through the BEAT process, we're able to procure that service and develop the plans that we already had on the table and move forward with that very, very quickly. So the original scheme, so before the original CHP was installed, looked something like this. The whole site was served via steam boilers. the oldest of which was 1974 to 2004. The boilers had been replaced. The pipework, as I explained, is at least 50 years old throughout the estate. And that was upgraded through the scheme to replace those old and failing boilers, to improve the efficiency of the installed services. I'm sure many of you would be able to recognize boilers that look much like this, or clarifiers that look much like this through your own estates. But the initial proposal was to move what was then our central boiler house to the right of your screen there in our old energy centre to a more central location. So where the words are steam distribution throughout, the energy centre was moved, as well as and locate our new CHP in a boiler house that will be managed by Veolia in the centre of the site, and distribute the network throughout, connecting to the existing steam pipework systems. And the scheme that was introduced was what we have before you. So CHP procured and installed through a new waste heat recovery boiler, using the existing steam boilers, serving the steam pipework that remained in place throughout the estate. So whilst we had a new energy centre, we had a combined heat and power system that was providing us with energy savings and tackling the carbon emissions at the time. We still had an estate that had an effective £7.5 to £9 million worth of backlog maintenance in its steam pipework, its calorifiers and condensate pipework. That was the initial scheme, and that took place in 2013. That's the picture of the CHP that was installed alongside the existing steam boilers, 2 megawatt CHP. And in receiving the accelerated HIP2 funding in September last year, circa £9 million that was awarded to us in our bid, we took advantage of that to tackle that infrastructure that had been left behind, and de-steam our entire site. There were 4 options that we looked at: partial de-steaming, total de-steaming, controls, configurations, and all sorts. But the most progressive approach was to bite the bullet and to de-steam the entire site, because effectively that feeds into an infrastructure and a plan of energy distribution that supports the rebuild of a hospital. Even if it were, and certainly didn't preclude any of the options on the table, even if we were to build off-site, we still have another 10 years of maintenance and ongoing service provision required through the installation. So we took the opportunity to progress with that as a preferred investment with the HIP2 funding to de-steam the site and put us on a path to achieve those goals that Stephen has been explaining, and at least provide us with the options for the future investment. The savings delivered to us are quite considerable, £1.2 million-ish, so guaranteed savings, with over 5,000 tonnes of total carbon savings. So for us, that was a worthy investment. But the origins for us were really in a different place. We had the opportunity to deal with our backlog maintenance, and in dealing with the backlog maintenance, we took the view that we couldn't just simply deal with the backlog maintenance, replace clarifiers and replace steam pipework. We had to be progressive with that. We had to have our eye on the future and decide where we wanted to be in the future, and that certainly was to take steps towards a sustainable future and decarbonising our estate. So let's see if this goes on to the next slide, please. So the graph before you is not too dissimilar to the one that Stephen showed earlier. You can see the pathway that we were on without the variation was very clear in red. That's the historic path with the CHP. So at the point that we installed that back in 2013, you could see the trajectory. There were significant savings. I don't think you'll be able to see my mouse, but if you look to to the left side of that graph between points 1 and 2. The area between the green and the red is the savings that we were making on site. And the trajectory, obviously, without doing anything, wasn't very positive, didn't look very good at all. If effectively over the lifespan of the scheme would not have been making any carbon savings. So it seemed right to us at the time, in dealing with all our critical infrastructure and backlog maintenance, that investing in something that would return a saving both carbon and open up the options for future development of carbon savings, whilst in the middle of our EPC contract with Veolia, was the right thing to do. So you can see with variation that is currently being installed, taking out the steam pipe, we're putting low temperature hot water network with new low temperature hot water boilers. You can see the kick just before item number 3, the pathway with the variation. And that puts us on a pathway where we get to 2026, 2027, which is the end of the current EPC contract, where we could switch off the boilers, or switch off the CHP, or have them retired and serve simply with LTHW. But at that stage, we'll be developing, through the process of our redevelopment, all the options that Stephen Heap and Stephen Downs have been talking about, how to incorporate now the next phase in order to put us onto a trajectory where we can continue that graph down to the levels that we would like them to be at and make our 80% reductions. That would be to incorporate things like heat storage, heat pumps, and variations of other innovations that may become available to us. So that's the brief overview of the story at Royal Berkshire Hospital. It is one whereby it does need funding, does need significant funding. There are options for funding through the likes of SALIX and other mechanisms through CEF. We've been in the fortunate position whereby we've been able to capitalise on the funding made available through the health infrastructure plan, and has put us onto a path whereby we can progress to where we need to be. And those new technologies might incorporate things like, as I said, heat sinks, heat storage, and heat recovery systems, and pump technology. So I hope that's been of some interest to you, just to see how we've embarked on our project. Never easy, certainly with the NHS spend lines by the 31st of March and having to do the bulk of the work in winter, losing a lot of resilience along the way, but certainly a worthy and worthwhile investment of energy and investment to move us to where we need to be. So I hope that's been of some help to you, and I think it's over to Jonathan.
Yes, thank you very much, gentlemen, for some really insightful discussion there about the scale and the nature of the challenge, and also some practical solutions as well. We've got a few minutes left, and we have a whole flurry of questions come in, so I will just launch straight into giving you some of those. The first question we received was from Dralon Nira, who's a supplier of ICS Cool Energy. And I think this reflects a number of questions around procurement, and particularly low carbon procurement. So how important is it for NHS Trust and other healthcare estates to consider or considering HVAC, aircon, chillers, boilers, that type of equipment, suppliers who consider products, services and applications of equipment that can save energy and cost to the estates, teams and trusts? Sometimes the cheapest option is not the most carbon friendly and is not the right application, i.e. applications that will use and reuse energy to be an overall solution on temperature control. So I think this is a reflects a general point about how do we ensure we're buying low carbon products, the right products, and not the cheapest products? I don't know who wants to start on that one.
I'll make a sort of general point that part of what we've been saying today is about having a strategy in place, and that's going to mean different things for different organisations depending on where you are. But I think without a rudimentary carbon strategy, particularly now that we have this gauntlet thrown down by the NHS with a timeline to achieve some significant carbon savings, if we don't apply some form of strategy to that, we have a danger of continuing with a bit of a sort of reactionary sort of ethos that sort of ignores where we've got to be. We carry on doing the same thing. So I think when we're considering re-procurement of particular pieces of infrastructure, we need to understand how does that fit in with our carbon reduction strategy. If we don't have a carbon reduction strategy, then clearly there's a danger that we may inadvertently go down blind alleys or areas or procure stuff that prevents us from making further savings in the future. And I suppose the worst position to be in is, we get towards 2032 when, in theory, we've supposedly have all contributed significant amounts of decarbonisation and find we haven't really achieved anything. So my point is, effectively, we need to get a strategy, even if it's reasonably rudimentary, and it will be a planned strategy. You can't do everything all at once. What are the most fundamental things that we need to do, and how does your HVAC replacement fit into that?
Okay, thank you. Stephen, you look as if you're about to launch into an answer there.
Yeah, I think just building on what Stephen just said is, and listening to the and on the question that you asked, I think it's about having carbon at the centre of the procurement. So if you've got your strategy and you know where to go, then it can't be a race to the lowest cost. It has to be a race to the best carbon savings for a given project. And I think it would be the procurement professionals which are in the space. Steve and I work with many of them closely, that will help guide us in creating invitations to tenders which can be responded to in a way that fit with that strategy. And I think that's going to be the cornerstone, because otherwise I think the question is quite reasonably raised that otherwise you'll end up with poor quality equipment which doesn't deliver, and then we all end up with sad faces, and that doesn't help our overall objective.
Yeah, absolutely right. Yeah, you agree with that, Guy?
Yeah, I think that strategy has got to be something that's made. It can't just be. It's okay to talk about strategy, but where do you find that? If it's not ingrained and written into policy, that is then driven through capital investment teams, maintenance teams, and those that are driving transformation projects. It becomes a bit nebulous. So it needs to find its way. That strategy has got to be something that is developed within the organisation, written into the policies, and adopted by everyone. And we've taken various approaches to different elements of, certainly on the hard services side. So the de-steam project's one of those. When you talk about chillers, we've just gone through a big project there where we talked about moving away from like-for-like replacement in existing infrastructures and existing locations to going to more modular build-up that can be relocated, adapted, modified, and that's a strategy that we've adopted, which doesn't lock us in long-term to any one solution. We have to be flexible.
Down to the specification, I guess, as well, and it's not just about the estates and facilities people, is it? You said procurement professionals are critically important in that as well. Another question from Christine Rishton. What does the panel think about the optimistic timescales to reduce the NHS carbon emissions? Would it make more sense to take more time and perhaps do a better job, or is the sense of urgency required to get things moving in the first place? That's a difficult one to answer. Who'd like to have a stab at that?
Well, it's one of those, isn't it, that I think there's the piecemeal approach, or is that there is that strategic long-term approach, but we're not all in that privileged position where we can, for example, at Royal Berkshire Hospital, we are in the privileged position where we're part of the 40 hospitals that's being rebuilt, so we can drive strategy now, towards the future. Other hospitals and other facilities might not be there, but it doesn't just, rely on replacing, hard services with more efficient. As Stephen said, we'll end up at the end of the day just buying rainforests to offset, which is no good at all. It's got to come in to innovative design of buildings, procurement, all these good things. One of the big areas of carbon footprint in the healthcare is in pharmacy. So it does affect absolutely everyone.
It does seem critical that we make a start, even if it's not perhaps the most strategic start in some regards. And I think it's really heartening that the NHS is, hospital trusts and hospital estates and facilities colleagues are taking the lead on this, across the industry in some regards. So I think it's great to take the opportunities we've got, particularly where, as in your case, Guy, you've got a lot of aged plant that really needs bringing up to standard.
And I think going to be progressively more, the government will have to look at progressively more funding for these kind of projects, because they do cost money to deliver. We have got a lot of aged infrastructure, but to have an ambitious target, I think, is important, because otherwise, there's lots of priorities in healthcare, and we need the driver to make these things happen.
And also we will need, and some of those drivers are probably going to come from changes in the way that we pay. So we may end up all paying through taxation. And as I say, the expectation is that the current carbon pricing regime is going to have to expand in order for UK PLC, as it were, to get to that position that we've nailed ourselves to. Even if you said, well, 2040 is still a long way away, but there is definitely, there's definitely going to be some shift in the way that we are taxed on using fossil fuel, and that's, we're talking about something that's going to change in the next year or so. That might change business uses.
Okay, there's another one. This is directed at you, Stephen L. As you've stated, this is from Martin Owen. As you've stated, the spark gap is as large as it has been for some time. The cost of hardware, such as heat pumps, are more expensive, and the electrical supply has to be upgraded and be on the essential supplies. Therefore, generators will need to be upgraded. We all understand it is the right thing to do as to maintain net zero carbon. Can the NHS afford this at this time?
Well,
difficult one to answer, but
well, sort of going back to what we've just been talking about, really. The sort of at one level, the answer is probably not. If you were just to look at this very crudely in terms of the cost of running a heat pump versus the cost of running a natural gas boiler. So at face value, without any form of help or subsidy, then it is clearly unaffordable. We have seen, as I say, some intervention in the last year with the PSDS loans that have helped in terms of the capital expenditure on re-procuring this sort of plant. That's likely to continue, but as I say, it still doesn't necessarily solve the conundrum in terms of the price difference between running a heat pump versus running a natural gas boiler. What we've seen with taxation on fossil fuels is nothing compared to what it's going to have to be. We've seen a 67% rise in climate change level on natural gas in the last 2 years. that's projected to increase further. And as I say, there's anticipated to be further announcements on further taxation likely to happen before the COP26 event in November this year, which is the next UN meet on climate conference in Glasgow. And it's very likely that the UK government will make some further announcement. Moving feast.
Absolutely. We're in the last sort of couple of minutes of our time. There's a question here. We've had so many questions, so thank you everyone for putting them all in. This one's on a slightly different tack, perhaps moving slightly away from some of the subjects we've been talking about, from Professor Robert McDonald. It says his question concerns the patient experience of hospitals and care homes in terms of temperature and ventilation efficiency. What NHS research has been conducted in terms of radical changes in optimum temperature and ventilation? Why are so many hospitals so warm and unventilated? That's an interesting point. I think that's got that one going.
Well, that's legacy. I think, well, it's legacy and controls. Again, an area where I could just speak at Royal Berkshire Hospital is much of our estate that doesn't have adequate ventilation that meets HTMs, and many areas that don't have any form of intelligent controls, no BMS control. You know, we got entire blocks that either have an on-off heating system, so you can walk into the estate in the middle of winter and they'll have windows open to reject some of the heat because there is no control within each space. Again, it comes down to investment. We've got all the technology available to us, but it needs money to invest in it. And back to what Stephen said, you know, these things are all achievable, but it does need money, and we're going to pay for it one way or another. We either pay for it, either our great-grandchildren are going to pay for it through the environment, or we need to invest in it now and meet these targets that we've been set, and it's going to need investment. So without that backing, you know, these and, you know, in acute hospital, we run 18 theatres at Royal Berkshire Hospital. They all have, you know, 25-hour change rates, so large volumes of heat that are required for those spaces. So yeah, new technologies such as we talked about, you know, heat storage, so that we can try and accumulate overnight and absorb during the day are technologies and investments that need to take place. But right now, unless the strategy is there to develop that, you're not going to be able to plug into those when you build a new theatre or when you build a new ward. So getting the strategy right is absolutely key.
There is a, sorry, so no, I'm just going to rush through a couple more because we are now out of time. There's one observation that I have just temporarily lost, but it was from Ian Allen at Kettering General Hospital. Just said, would it be possible to meet with Guy to learn more, as they're now reviewing their options at Kettering. So as Ian now knows where you are, Guy, and who you are, I'm sure he will make contact on that. But I think that's important. I think, for, you know, IHEAM and HEFMA, you know, both champion the cause of sharing experience and sharing knowledge. So I think it's critically important that we continue to do that.
Yeah, absolutely happy to do that. Yeah.
There is one other point. I'm just going to ask one more, and I'm sure someone will be shouting at me shortly that we're out of time. But the question comes from Stephen Bentley. It says, no clear guidance is provided in the route map document regarding embodied carbon of new build HIP-funded hospitals, and if this embodied carbon needs to be taken into account in reaching net zero carbon by 2040, well, that is the observation. If embodied carbon is included, the extent of carbon offsetting either on-site or off-site is considerable.
Yeah, so embodied carbon, obviously, in terms of the carbon footprint of materials, building materials, or building methodologies, etc. I think that would come under the NHS carbon footprint plus, and there is a under that carbon footprint, effectively there is a band of influence that might come from construction, and I think the inference there is that under the carbon footprint plus, the NHS is going to have certain expectations over their supply chain in terms of what the supply chain can do and what expectations in terms of reducing carbon footprints in terms of the services that supply chain are responsible for. So I suspect that a lot of this is going to come through, demonstration of that choice of materials, embodied carbon, etc., through the NHS's choice of construction. That's like as a value an infinite value in terms of tonnage of carbon per year, etc. That doesn't necessarily appear as an absolute value in some of these curves we've been looking at. But it might very well, as I say, come into particular projects that get to the NHS.
I mean, that speaks, Stephen, to our frameworks and model hospital directives. So there's a lot of work to be done there by procurement mechanisms and certainly a model hospital construction, modern methods of construction. There's a big role to play there.
It certainly highlights the magnitude of the challenge that we're all facing, doesn't it, really? I think we could, there are a whole host of questions we haven't even touched on here. I'm sure we could spend, a whole day talking about this subject, and perhaps that's an indication that maybe we will do some more of these events between IHEMA and HEFMA and CEF as well going forward. So all that remains really for me to do is to thank you all three for your presentations this afternoon. We've well and truly run out of time, but if you have any more issues you want to discuss, then please visit Carbon Energy Fund's website, IHEMA's website, HEFMA's websites, where you can find further information and make contact with various people as well. We will be doing some I think mop up on some of the questions, hopefully, so it's possible we might actually be able to give some further answers to these, but if not, perhaps we'll use them to build a future session for everybody. So thank you all for your attendance today. Thank you for your time in supporting this event. If you wish to join the next event, which is at 3 o'clock in half an hour's time, thereabouts, to look at Nottingham Hospital's practical examples of progressive decarbonisation. That sounds like that would be a very good session as well. So that's at 1500. So thank you very much indeed, and we'll say goodbye at that point. Thanks very much indeed. Cheers. Bye-bye.
Bye-bye.